So now for the second version, we want to do the following. Specifically, we want to target this particular point. We want to say that as soon as the has duplicate over here has been set to true, we want to exit from the loops, both the inner loop and also the outer loop right away. So we can use a Boolean variable as we learned previously for the the non-nested loop, right? That's what we learned. Let's now see version 2. So that's exactly how we can transition from one version to the second one. Not the ultimate version just yet, but we can see some improvement. So let's see version number 2. The only thing we have changed, as I highlighted over here, let me highlight it again. You can see it's really here. So we introduce in the exit condition. Let me just try to highlight, maybe using the pen over here. You can see this part over here is the state condition for the outer loop, and this part over here is the state condition for the inner loop. Right? So we just introduced to both of them. It's really important to say that. So that means as soon as has duplicate over here becomes true, meaning that we have found the satisfaction witness, in that case, not true is going to be false. Not true is going to be false. That means we are not going to go any further for either the inner loop or the outer loop. We're going to exit from both of them right away. Right? That's how we control the entrance or exit for the loop. Now let's now take a quick look. In terms of the combination for the loop counters, we still got when I is equal to 0, we got 0, 1, 2. 1, we got 0, 1, 2. And also 2, we got 0, 1, 2, right? So now in the case where there is simply no duplicates, so that means we cannot really do early exit, right? So you can think about this second version here, when there is no duplicates, you're still checking things that are actually unnecessary and also redundant. For example, you can see here, for the second version, we are still checking 0, 0, and also 1, 1, and also 2, 2, right? We talk about they are really unnecessary to check. And similarly, we are also checking over here. For example, you can see we already checked 0, 1. That should be enough. We don't have to check 1, 0 once more. And similarly, for 0, 2 versus 2, 0, and also for 1, 2 versus 2, 1, right? You can see still quite a bit of redundancy over here for second version when there are no duplicates in the input array. But what if there are duplicates in the array? Are we going to see some improvement? The answer is yes. Let's now move on to the still second version here, but we do have some early exit. So which is why we want to transition from at least from version 1 to version 2. And let's take a look here. So we don't have the duplication in the body of the loop anymore. We see, oh, this may not be a good color. Let's now see this. Let's just highlight it. So here we don't have any accumulation. That's something we learned. This one is more like a version number 4 in the previous lecture when we talk about checking existential versus universal properties. So now we simply just assign the value of the Boolean variable initially false to be the truthfulness for this Boolean expression, which I explained already. So now you can see that when can we find the first satisfaction witness? Well, exactly when I is 0 and j is equal to 2, right? Exactly over here, right? So that's really the row I highlighted before over here, right? You can think about this row over here correspond to exactly this row that I spoke about in version number 1. And the disadvantage for version number 1 was that we still have to continue with the rest of the tracing over here, the rest of the execution for the rest for the remaining combination for I and j. However, in this case, as soon as you can see, as soon as has duplicate has been set to true over here, so we will know that not has duplicate will be false, and also not has duplicate will also be false, right? The negation of true should be false. And then we're going to exit from the loop right away. So we're going to bypass this part over here, and when we go back over to the header for the outer loop, we're also going to bypass the body of the loop. So in some way, this is really good, right? So you can say this will actually cost early exit. Early exit as soon as a satisfaction witness is found. Satisfaction witness is found. And in our case, since we are checking the universal property, existential property, so the satisfaction witness in this case will be the witness for duplication, right? So that's exactly this particular condition is about. All right. So these are the two cases for version number 2. So version number 2 definitely is an improvement from version number 1, especially when you actually got input where you actually got duplicates, right? But still, we would like to avoid the redundancy, like us checking 0, 0, and also having checked 0, 1 already, but we're still checking 1, 0. We would like to get rid of these two redundancies. So since like we may have to play with how we update the loop counters, especially you can see in version number 2 and version number 1, J always start from 0. So that means we got 0, 0. Wouldn't it be possible to maybe play with, massage the value of J a little bit so that we can get away from having duplicates, right? That's something we'll see. I mean, duplicate for the loop counter.